Two perpendicular straight wires join the ends of a semicircular loop of radius A. So these two perpendicular straight wires are joining the ends of a semicircular wire. If the current I is current is I, the resultant field at the center of the circular section is given by. So this one, magnetic field here, is given by x into 1 by a 10 to the power minus 7 Tesla. I by a into 10 to the power minus 7 Tesla, then x is. So x into I by a into 10 to the power minus 7. So you have to find out this x. Okay. Now let us try to find out, and we can divide the whole system into three parts. One, this semicircular wire. Two, this is a straight wire carrying current, and the current will pass like this here. This is the third part. So how will be the magnetic field produced at the center here due to all the three components? Now if you take this semicircular wire, this one, how will be the magnetic field produced at the center? Now you have to use the clasp rule. You have to hold all the fingers of the right hand in the direction of current like this. Then the thumb represents outside. So you can hold your hand like this. So show all the fingers in the direction of current. Then the thumb shows the direction of magnetic field at the center. So we usually use this principle to find out the magnetic field at the center of a coil. So if you hold it like this, then the thumb will move outside. Or you can do like this well. So you can use the clasp rule by clasping the conductor with your right hand. So you clasp this conductor with your right hand such that thumb shows the direction of current. Then the remaining fingers will show the direction of magnetic field. So when you clasp it like this, with the thumb showing in this direction, then the remaining fingers will have to encircle like this, like this, like this, like this. That means they will show the direction like this outside here. So encircling fingers will come like this, like this, like this. So it will be coming out. So magnetic field due to the circular part of the wire is coming out of the board. So that is clear here. Now, what about this conductor? So if you take a straight conductor carrying current like this, clasp it in such a way that the thumb shows the direction of current and with right hand, so and the remaining fingers will show the direction of magnetic field. And if the thumb is showing here like this, then the fingers will encircle it like this, like this, like this, and these fingers will come outside here, here, here. So they will be coming out here as you clasp it with the right hand. So due to this conductor also, the magnetic field is coming out here. Now clasp this conductor with the right hand. When you clasp this with the right hand, such that the thumb shows the direction of current, then the remaining fingers will come like this, like this, like this. So hand will be like this. So they will be coming out here in this part. So again, it will be outside. So magnetic field due to all the three components, the two straight part conductors, as well as the this curved semicircular wire, all the magnetic fields are coming out of this point. So you can add them. So I'll name this as 1, 2, and 3. Now, so the net magnetic field at the center O is due to 1 plus 2 plus 3. Magnetic field due to the first part of the coil, semicircular coil. Second, that is straight wire. Third, another straight wire. Now, what about the magnetic field due to the straight wires? And you have to use this formula. If a straight wire is carrying current, and if you select a point here, then if the two ends of the wire are connected to the ends of the connected to a point here, then if this is the point where I want to measure the magnetic field, and if this distance is r, then if this makes an angle phi 1 or theta 1, this makes an angle theta 2, then magnetic field here is mu naught by 4 pi I by r into sine theta 1 plus sine theta 2. This is the formula. So magnetic field due to the straight part of the wire, which is not infinitely long, of some limited length, the magnetic field at a distance r from the wire at this point, and if you join this point to the ends of the wire, if they make an angle theta 1 and theta 2, then magnetic field here is mu naught by 4 pi I by r into sine theta 1 plus sine theta 2. This is the formula. So magnetic field due to the straight part of the wire, which is not infinitely long, of some limited length, the magnetic field at a distance r from the wire at this point, and if you join these points to the ends of the wire, if they make an angle theta 1 and theta 2, then mu naught by 4 pi I by r into sin theta 1 plus sin theta 2. So now if you want to find out all these things, theta 1, theta 2, etc. Radius of the semicircular wire is given as A, so you have to use it now. How to use it? Now if you join this here, this will be A. And if I join this as a perpendicular to the second wire here, if this is 45 in this right angle triangle, I will join it by lines, blue lines like this. If this is 45, then if this is 90, then the remaining angle is, this should be 45. This is already 45, this is 90 because I have drawn a perpendicular line, then this should be 45. That means this is also 45. Because if this is 45, then this is 90, okay, this is A. And of course, you can find out all these things now. Now, suppose I want this as R. How to find out R now? If you want me to get that value, okay, these are perpendicular lines. Then this should be, if this is 45, this should be 45. I can take 45 degree here. This has 45, and I can take R. This is hypotenuse A, and I have adjacent side R. So cos 45 is equal to here. So I will redraw it. Yeah. I'll drop a perpendicular from here. This is 45. This is also 45. This is A. And I'll take this as R because I want this perpendicular distance. If this is R, then cos 45 is equal to adjacent side by hypotenuse. R by A. R is equal to A cos 45, which is nothing but A by root 2. So this is R is A by root 2. Now this part can also be found out. I think it is not needed. A sin 45, whether it is needed, this opposite side. Okay, this one. I take it as X. Then if I want X, I can take sin 45. Then sin 45 is opposite side by hypotenuse. Then X is also is equal to A sin 45 A by root 2. So this is A by root 2, this is A by root 2. Of course, if it is a 45 degree isosceles right angle triangle, the two sides should be equal. Yes. Okay, now using these values, you have to find out the force. And I can, sorry, not the force, net magnetic field. Net magnetic field at O. Magnetic field due to 1. 1 is a semicircular wire. So magnetic field at the center is mu naught I by Ni by 2R. So mu naught N is half number of turns. So mu naught N, I is I by 2 times radius A. Here radius is A, mu naught Ni by 2A. So N is half, semicircular, plus magnetic field due to this straight part of the wire here at the center. So you have to apply this formula, mu naught by 4 pi I by this distance. That distance we have already found out, A by root 2. A by root 2 into sin theta 1 plus sin theta 2. Sin theta 1 plus sin theta 2 is sin 45 degrees plus sin 45 degrees. That is 1 by root 2 plus 1 by root 2, which gives you 2 by root 2. 1 by root 2. And this has to be written 2 times because this part of the wire will also produce the same amount of magnetic field, which is also coming out of this point. So I can write it as 2 times. 2 times. So what is the net magnetic field at the center? B naught is equal to, of course, I want pi to come out because finally they have cancelled pi also here. There is no pi. Yeah, maybe answer in terms of pi also. Yeah, so I have to take mu naught by 4 pi outside the bracket. So here I have 4. So I will multiply by pi and divide by pi. Mu naught by 4 pi and I will write pi. So 2 into 2 is 4. I by A plus Then here mu naught by 4 pi, I will take it outside. And this is 2 by root 2, I by a by root 2. This is 2 by root 2, and again 2 times. This root 2 and this root 2 can be cancelled. 2i by a, I have 4i by a. So mu naught by 4 pi, 4i by a, yes. B is equal to, B naught is equal to mu naught by 4 pi, I by a. So much I have common in both. I can take it outside. Mu naught by 4 pi, I by a. So pi is the extra thing here. Pi plus, here mu naught by 4 pi, I by a plus 4. So 2 into 2 is 4. Rest of the things are same. Yes, that implies mu naught by 4, B is equal to B naught is equal to mu naught by 4 pi I by a into 3.14 plus 4, 7.14. Okay, so this is 10 to the power minus 7. That implies B naught is equal to 10 to the power minus 7 I by a into 7.14. How should it be the answer? So x into I by a into 10 to the power minus 7. So in the place of x, I have, so this should be x into I by a into 10 to the power minus 7. So in the place of x, I have 7.14. So x is equal to 7.14. That is answer. Thank you.